think are the appropriate bearings. So what we have is
so for A, it lists the
yes, diameter will be 50 millimetres.
yeah. So yeah, it will be 50.
Okay, now point B.
B.
We've got a much smaller diameter. I think it's 25.
B. Here. Yeah, this will be.
Okay. Now we have to think what the
motor. Is a motor.
what the pulley sizes will be. Now, do we have the pulley catalogue? So we essentially the pulleys didn't actually specify what I saw how we is there a minimum how do you specify the shaft that goes through the pulley? We'll try and find the concentration, that's a motor, belt drive, that's what we're after. Okay. How does this actually fit? It may not say. I think we may need to go and find the remainder of the catalogue. Okay, I'm just going to go and pause the camera. I'm going to go and get a full copy of this catalogue. It's not available online, unfortunately. Okay, so start again. Okay. Right, so
it appears that by looking back at the calculation for
the bearings, we noted that we changed on. We used one roller and one ball bearing. Ball bearing designed to provide some axial location. One of the issues is that the dynamic loading has a factor which changes between ball bearing and roller bearing.
okay.
So we should perhaps revisit our calculations for the ball bearing. We took just for the roller bearing.
Okay, so for roller bearing, the factor was
10 upon 3.
10 over 3.
Whereas it's 3 for a ball bearing, so it's slightly higher for a roller bearing.
Yeah.
So what we want to do is revisit.
Okay,
so
and it was at location A.
Location A, we chose a ball bearing.
Okay, so I should revisit calculation for ball bearing
Exactly
at location A, yeah?
Yes.
Should I put a revisit?
Yes.
That was in page 19.
So on page 20 we go through choosing the bearings, so some of those will be revisited.
Okay.
And page 21 says...
Still number is page 22 anyway.
That's correct, yeah. Right, so what we have is...
I put that from page...
Yeah. We're going to revisit the calculation to work out the duty cycle, basically.
Yeah.
So
at
what,
location A, okay?
so the dynamic loading, the duty cycle of course remains the same. It's the dynamic loading, or the factor due to the dynamic loading changes.
Okay.
Because so what we actually have is
So
if
we
we just
should
take
have
that,
L equals to C over P to 3 this time, yeah?
to
For ball
3.
bearing.
To 3. So what we have is C is equal
It's
L.
3 or 1 over...
No, it's
3, isn't it?
Yeah.
Yeah.
Yes.
Okay.
So what we actually have C is equal to L to the power of a third. Multiplied by P. Okay.
Yeah.
So L we said was 346
3, 4...
times 10 to the 6. I'm not sure how you do to the 10 to the I suppose 6
Yeah.
zeros.
Is it 3 to the...
No, that's sort of newtons. The actual...
It's 3.48.
Sorry, that's
That's
what
the
I'm working out at the moment is just what the factor is. Essentially, P is our static
It's the
load.
load, yeah.
I just want to work out the factor, which
Yep.
is L.
So
for
L
life.
was
348.
348.
Oh, is it 348? Excuse me.
Yeah.
348. I'm glad you checked that. 348 times 10 to the 6, and essentially that becomes to the power of a third.
Yes. And then the load is 3479.4 Newton. Okay? Just calculate that.
Oh, excuse me. Also, we noted last time that when we do this equation, that L is in millions of cycles.
Yes. So it's 348.
Which I didn't do last time. So, okay, which gives us 7.03.
Okay, multiply with the load, which is 3479.4.
Yes.
What's the value?
Multiplied by, sorry, is it
479.4.
3.4 gives us an answer of 24473.6.
6.
Newtons.
Okay,
So
newtons. So it's in
higher.
24.5 kilonewton. Okay.
So we have to, as it actually transpired, when we choose our bearings, we're choosing more in the geometry, as in we have to provide the bore diameter for the bearing has to be large, because we still require a strong enough shaft outside of it to support the motor pulley.
Yes.
So we said, just
So
as
we
a
need
starting
a
guess,
step, but we don't want the
Step.
step to be too drastic.
well, essentially we just need a feasible step. We actually need when it steps down to still be big enough that we don't fail under stress, or
Yeah. Yes. But we can first select the small, the big enough bearing now, and
yes.
revisit that.
If that's what we wish to do, yes.
Yeah.
Now what we're going to do is we're going to choose it from the SKF catalogue under
Okay.
the bearing units, which is a Y bearing, which is essentially the deep groove ball bearing in a plumber block.
Right.
Now, what we want is, we're just going to choose a cast housing.
So which type are we going up for?
Okay, it's not particularly clear what the overall difference is, but cast housing,
Cast housing. Why cast?
no real preference. We have the choice of cast, short base, or pressed steel. Now, when we actually go into the pressed steel, they all look very much the same in terms of what types of the dynamic, the values for dynamic loadings don't look so different.
Yes. But that's just the type of the housing.
It's just a type
There's
of the
not
housing. There's no real preference for that.
constraints on our.
No. We just needed to take the bearing that we're after.
Okay, so
Now-
this is cast housing eccentric locking core.
Yes. Now, what was the dynamic loading we have to design for?
24.5.
Kilonewtons. Okay, so there's 25.5 kilonewtons with a static of 15.3.
So
The static's fine. Static was,
static C not.
is that 3.5 kilonewtons? Is that? What was the static load? It's 3.5 kilonewtons or something of that nature, wasn't it?
Static load.
Well,
what do you
just
mean?
as a bearing reaction force. What was the bearing
Right, the
reaction?
P.
Yeah. Yes, 3.5 kilonewtons roughly. So
So are we safe?
static's fine. 15.3 and 25.5 for the dynamic. Has a speed rating of 5,300 revs a minute, which is much faster than we need.
25.54 dynamic.
Yeah, it's only just larger, but we can start with that and see what we have.
Yeah.
Designation for the bearing housing in SY35WF. The housing, that's for the bearing, sorry, for the housing unit, SY507M.
Sorry.
Bearing.
Housing is
SY507M. It says for the bearing, I don't know what's the difference between the bearing and the bearing unit, but the bearing is YEL207-2F.
L207-2F. So this is the bearing unit.
Now, what we find is we have an eccentric looking collar on this one. What we have is the, in terms of dimensions, the actual axial amount of shaft,
Mm-hmm.
the length of shaft going through the bearing is 51.1, I'm not sure what you call that, the width of the bearing.
The contact length.
The contact length is 51.1 millimetres. The bore
51.1 millimeters.